Okay, so on notes 6.3, we're going to be graphing more quadratic functions. On the front is a review from 6.1, or actually 6.2, when we were using the vertex form and root form in order to graph our quadratic function. Okay, so on number 1, the first thing that you need to do, you need to figure out what form it's in. And so if you look at vertex form, root form, and look at number 1, notice that it is in vertex form. So if you write that above it, y equals a x minus h squared plus k. Remember, h, k on vertex form is your vertex. So h, notice, would be a positive 1, and then your k is a negative 4. Okay, so I want you to put that in your table. So 1 and negative 4, and then you're going to choose 3 x values that are either greater than 1 or less than 1. Okay, so I'm going to choose 2, 3, and 4. Okay, if you didn't have a calculator, you'll just be plugging it in to your equation. So y equals 3, and then replace x with 2. So whenever you plug that in, you should get negative 1, because that would be 1 squared. So 3 minus 4 would give you a negative 1. Okay, if you plug in a 3, then that's going to give you 2 squares, so that would be 4. So 12 minus 4, you should get 8. And then plugging in a 4, so that's 3 squared, that would give you 9, which would give you 27 minus 4, so you should get 23 there, which is going to go off our graph, so we're not going to be able to plot that. Okay, so let's go ahead and start graphing. So we're going to go ahead and plot our vertex, which is 1, negative 4. Okay, and then we have our axis of symmetry that will go straight through your vertex. And then plotting your other points, 2 and negative 1, 3, 8. And then notice the other one goes off the graph. Okay, so to find your other points, you're going to reflect those across your axis of symmetry line. And then you should be able to find your other half of your parabola. So then we're going to connect your points, and then you would have your parabola. Okay, so if you look at number 2, notice that this is not in vertex form because we have two different x's. So this is root form. Y equals a x minus r1 x minus r2. Okay, so let's figure out what our roots would be. So root 1, notice that there's no parentheses, so root 1 would be 0, because x minus 0 is the same thing as x there. And then looking at r2, that would be a negative 2. Remember, it's the opposite there, because on the form it's subtracting. So that would be x equals a negative 2 for that one. Okay, so remember we talked about on root form, we're going to plot the two roots, which are your x-intercepts. So 0 and negative 2. All right, so then remember I told you that your vertex is in the middle of those, because the vertex is in the middle of your parabola. Okay, so our x value of the vertex would be in the middle, which would be at negative 1. And then if you didn't have a calculator, you're just plugging it in. So that would be 1, so you would end up getting negative 3 for your y value. So negative 1, negative 3 would be your vertex. We can plug that into our table here. And then we can either choose 3 values that are either greater than negative 1 or less than. It doesn't really matter which way you go. So that would be negative 2, Actually, I'll do 0. Let me erase that real quick. So that would be 0, 1, and 2. Notice we already have the 0. That was 0 because that was one of our roots. If you plug in a 1, into your original equation, you're going to get 3 here. So that would give you 9. And then if we plug in a 2, that's going to be 4, so 24, which is going to go off of our graph. So the only one that we're going to be able to plot from our table that we haven't already plotted is 1, 9. Drawing your axis of symmetry line, it goes straight through your vertex, and then you can reflect over to find that other point on the other side. And then you should be able to connect all your points and make your parabola. Okay, so we looked at both vertex and root form, which we already looked at on 6.2. Now we're going to look at standard form on the back. Okay, so standard form, we really kind of already talked about it whenever we were using the quadratic formula in standard form. You have ax squared plus bx plus c equals y. And then to find your vertex, there's going to be a formula for finding the x value. To find your x value, it's written right here. It's negative b over 2a. Okay, so once we find that, we're just plugging it into our original function, and then we'll find the y value. The y-intercept is going to be your c on your quadratic function whenever it's in standard form. Okay, so we're first going to find our vertex. So to find the vertex, we're doing negative b over 2a. So let's write down what a, b, and c equal. A equals a negative 1, because that's the coefficient of x squared. B equals a negative 2, that's the coefficient of x. And then c is your constant, which is 8. That's also your y-intercept, so where it will cross the y-axis. Okay, so plugging into this formula, notice in the formula it's negative b. B is already a negative, so that will make it positive 2 over 2 times a negative 1. So that would be 2 over a negative 2, so our x would equal a negative 1. That's the x value of your vertex. To find the y value, you'll just plug it in. So that would be negative, and then we're plugging in a negative 1 squared minus 2 times a negative 1 plus 8. Okay, so order of operations, we need to get rid of our exponent, so that would be positive 1, but we have a negative in front. Multiplying these two would get positive 2. So that would be 1 plus 8, which would give you 9. So negative 1, 9 would be your vertex. I'm going to go ahead and plot that. So that point there. Okay, so we're going to go ahead and put that in our table here. Maybe. So negative 1, 9. Okay, so I'm always choosing 3 x values that are either larger than negative 1 or smaller than negative 1. It doesn't matter which way you go. Okay, so I'm going to use 0, 1, and 2. Okay, all right, we should already know the 0 one because that's your y-intercept, and remember at the top we said that was our c. So if we plug in a 0, we're going to get an 8. Because that was our y-intercept up at the top, it said, in standard form. Now we'll plug in a 1. So that's going to be -1 because we square 1 and we get 1, but there's a negative in front. Then -2 plus 8. So that would be a -3 plus 8, which would give you 5. And then we'll plug in a 2. So y equals negative, and then 2 squared minus 2 times 2 plus 8. So that would be -4 minus 4 plus 8. So that would actually give you 0. Okay, so let's plot those points. 0, 8, 1, 5, 2, 0. I'm going to draw my axis of symmetry line that goes straight through your vertex. And then you can reflect your other points over that axis of symmetry line to find your other points on the parabola. And then you can connect. And there you have your graph. So when it's in standard form, in order to find the x value of your vertex, you will plug into the formula -b over 2a. Okay, so let's look at this last one. It's number 4. Notice that it's also in standard form. So let's go ahead and find a, b, and c. So our a will equal 2, b will equal 8, and c, remember, which is the y-intercept, is 6. So to find the x value of your vertex, we're plugging into -b over 2a. So that would be -8, because b is negative on your formula, over 2 times a, which is 2. So that would be -8 over 4, which equals a -2. So there's your x value of your vertex. To find the y value, you're going to plug it into your original equation. So y equals 2 times a -2 squared plus 8 times a -2 plus 6. So get rid of your exponent. That's going to give us 4 times 2, which is 8. That'll be minus 16 plus 6. So that would be -8 plus 6, which equals -2. So there's our y value. Our y value of our vertex is -2. So I'm going to write that in my table, -2, -2. And then I'm going to choose 3 x values that are either larger than -2 or smaller than -2. It doesn't matter which way you go. I'm going to do -1, 0, and 1. Okay, so plugging in a -1. We're going to get, that would be +1, so that's 2. And then that would be -8. And then we have a +6. It wouldn't write right there. There we go. So that would be -6 plus 6, which equals 0. Okay, so we know the 0, when x is 0, you have a y-intercept, and we know the y-intercept is our c value, which is 6. And then we're going to plug in a 1. So that's going to give us 1 times 2, which is 2, plus 8, plus 6. So that would give you 16, which is going to go off of our graph. Okay, so let's plot -2, -2, which is our vertex. And then -1, 0. 0, 6. And then 116 goes off the graph. So I'm going to draw my axis of symmetry line and then reflect those points on the other side. This pen doesn't do very well when you're graphing. Okay, so we have vertex form. It helps you find your vertex HK. We have root form. You find the two roots, which are your x-intercepts, and then your vertex is in the middle. And then when you have standard form, you're using the formula x equals a negative b over 2a to find the x value of your vertex. And then, of course, to find y, you can just plug it in and find what y would equal.